Hello guys, let's talk about oxidation number calculations involving the polyatomic ions. Alright, now right on the board I have nitrate ion, sulfate ion, dichromate ion, and the other one. In here we're going to calculate for the oxidation state of nitrogen. Here we're going to calculate for the oxidation state of sulfur. Here we're going to calculate for the oxidation state of chromium. Okay, now how do we go about this? You must be knowing that nitrogen, we're going to say NO3 minus equals to minus 1. We'll simply equate this to the net charge it bears, it carries, which is minus 1. So for this, it's going to be SO4 2 minus equals to minus 2, which is the charge. Okay, here is minus 2. So it's going to be Cr2O7 2 minus equals to minus 2. So that is how we go about it. So that is the very first step. But if it is a neutral compound, you don't have to do that. You have to equate to 0. Okay. For example, if I have something like so, I have, let's say I want to calculate for the oxidation state of KMnO4. Okay, I want to calculate for the oxidation state of manganese. So this is a neutral compound, so I'm going to equate it to what? To 0. But for a charged, for charged species, it's usually equated to the net charge. Okay. All right, that's the very first thing you must know. Okay, now what else do we need to do? We already know we are going to sum up the oxidation number, right? So now nitrogen is what we're looking for, right? We're looking for the oxidation state of nitrogen in nitrate ion. So we're going to say N plus oxygen is minus 2 times 3 equals to minus 1. Okay, so nitrogen becomes minus 2 times 3, that's what? Minus 6 equals to minus 1. So we're going to say, now plus minus is minus, so this becomes N minus 6 equals to minus 1. So minus 6 is going to cross, we're looking for nitrogen. So minus 6 is going to cross the sign of equality to this side to become plus 6. So it becomes N equals to minus 1 plus 6. So that will ultimately give us plus 5. So the oxidation state of nitrogen in nitrate ion is plus 5. So this is a nitrate ion. So the oxidation state of nitrogen here is plus 5. So we can say triazole nitrate 5 ion. All right. So for this sulfate ion. So what is the oxidation state of sulfur in sulfate ion? So it's going to be sulfur plus oxygen is minus 2 times 4 equals to minus 2. So sulfur plus minus 2 times 4, that's minus 8 equals to minus 2. Plus minus is minus, so minus 8 equals to minus 2. So minus 8, we cross the sign of equality to this side to become plus 8. So it becomes S equals to minus 2 plus 8. That gives us plus 6. So you can see that the oxidation state of sulfur in sulfate ion is plus 6. All right. So that's why it can also be called, this is tetraoxosulfate 6. Tetraoxosulfate 6. So the oxidation state of sulfur here is plus 6. So this is how the oxidation number for polyatomic ions are calculated. Now let's take a look at this. This is dichromate ion. All right. So how do we calculate for the oxidation state of chromium? It's still the same pattern. Okay, we have to follow the same pattern. Okay, so now we've already equated to the net charge, which is minus 2. So we're going to say 2 chromium plus 2 chromium, CrO2 can still be written as 2Cr. Okay, which means we have 2 chromium here, plus oxygen is minus 2. Oxygen is minus 2 except in peroxide where the oxidation state is minus 1. Okay, and in superoxide where the oxidation state is minus half. So minus 2 times 7 equals to minus 2. So 2 chromium plus minus 2 times 7, that's minus 14 equals to minus 2. Plus minus is minus. 2 chromium becomes minus 14 equals to minus 2. Now minus 14, we have to cross the sign of equality to this side to become plus 14. So it becomes 2 chromium equals to minus 2 plus 14. That gives us 2 chromium equals to minus 2 times 14, minus 2 plus 14. That gives us plus 12. So we're going to divide both sides by, we're going to divide both sides by 2. okay, 2. So when we do that, chromium becomes what? Plus 6. So this is the oxidation number or the oxidation state of chromium in this polyatomic ion. Okay, so let's quickly talk about chromate. If you take a look at chromate is like so. This is chromate. So if we are to calculate for the oxidation state of chromium here, you can see the difference. This is not, there's no 2 here. Okay, so this is dichromate ion, this is chromate ion. So this is going to be CrO4 minus equals to -1. Don't forget that the very first thing to do. So the next thing is going to be CrO plus chromium plus oxygen is -2. -2 times 4 equals to -1. So chromium plus -2 times 4 is what? -8 equals to -1. So plus minus is minus. So chromium becomes plus minus is minus. So -8 equals to -1. So -8, we cross the sign of equality to this side to become +8 because this is what we want to make the subject of the formula. This is what we are looking for. So chromium becomes -1 plus 8. So that gives us +7. So the oxidation state of chromium in chromate ion is +7. Now let's quickly take a look at this. This is a UTME question 1989, question number 24. This particular question was asked. Okay, so it says an element Z forms an anion whose formula is this. If Z has an oxidation number of +2, what is the value of Y? How do we solve this question? It's simple. Now we've already been given the oxidation number of Z is given to be +2. We already know that cyanide, okay, cyanide, the oxidation number of cyanide is -1, isn't it? So we already know that. So we can easily impute these values into the formula and we're going to get the value of Y. Now you know the very first rule that must be obeyed, okay, which we're going to write like so. Z, okay, so here we're going to have Y, okay, equals to Y, because this net charge, whatever we have here, we are going to equate. Just like when we have 2 here, we equated everything to -2. When we had -1 here, we equated to -1. The same thing here. All right, for sulfate, when we had SO4 2-, what did we do? We simply said 2 minus -2. We have to equate to the net charge. All right, so now the net charge is Y, so we're going to equate to Y. So we're going to say Z is known to be +2. So +2, okay, let's just write 2. Okay, you know it's plus cyanide is -1, right? -1 times 6, okay, then what next? Equals to Y. Okay, so that's what you do. So 2 plus -1 times 6, that's what? -6 equals to Y. So plus minus is minus, so it becomes 2 minus 6 equals to Y. So 2 minus 6 is -4 equals to Y. Therefore, Y becomes what? Equals to -4. So this is what we have. So the question says an element Z forms an anion whose formula is this. If Z has an oxidation number of +2, what is the value of Y? So our value of Y is -4. Okay, so which therefore means that when we want to write the particular formula of the polyatomic ion, is going to be written as ZCN6 then 4-. So this is how it's now going to be written. So because the value of Y is now known to be what? -4. Okay, all right, this is the end of the tutorial video. It's Dr. Cliff. Bye for now.